Okay, kids, here we are with our first video of 2017. What Miss McNamara and I decided to do with most of the sections in Chapter 5 is we're going to flip them. So for those of you who are new to the word flipping your classroom, this is where you are going to actually, for homework, be learning the new content. And then during class, you're going to be doing a lot of practicing of that new content. So we're going to try this with Chapter 5 and see if we like it, and make some decisions for our leftover chapters. So very quickly, we're going to just take a few minutes to remember where we've been. So we're given these two pieces of information, which hopefully you get rid of the rust here, and you remember that in this case, they're trying to tell you that sign's positive. And in this case, we can see that definitely here, if secant is negative, then the cosine is also negative. So you would need to then figure out where you are, what quadrant are you in, where the cosine is negative and the sine is positive. So hopefully it hasn't been that long. We're going to draw our triangle in quadrant 2, put a little angle symbol in there, and we're going to label the information. So we know that secant is hypotenuse over adjacent, and we know that the hypotenuse can never be negative. So the hypotenuse will be 3, and this will be negative 2. And then we remember that this is going to be our a value. And so in order to find that, you're going to do a squared plus b squared equals c squared. So a squared plus negative 2 squared equals c squared, which is 3 squared, and you're going to solve for a. So we've got a squared equals 9 minus 4. So negative 2 squared is a positive 4, and we're subtracting it, so this is going to be 5. And so a, technically, is plus or minus the square root of 5, but because sine is positive in that quadrant, we're going to go with just the positive root 5. So what you're going to do for me is I'm going to pause the video. You are going to list out all of the remaining things. I'm not going to do this for you. Several times during this flip, I'm going to ask you to pause the video. Whether or not you choose to do that is up to you. But if you are not actually doing these things, then when you get to your in-class practice, which counts as a grade, you're not going to be able to do it. So make sure you are. So you're going to give me all of the remaining values that have not been said yet. Don't forget that you have to have an angle symbol in there. So work that out, and I'll be right back. Pause the video. Okay, so I hope that you have successfully maneuvered this review problem. Make sure you've got all your negatives in the right place. Make sure that your answers for cotangent and cosecant have been rationalized. And so now we're going to move on to some stuff that we're going to be doing in section 5.1, and I know you're going to be very excited to see this, some of you will, that your puzzles, your identity puzzles are back. So you may want to refresh your memory with some of your identities, your Pythagorean identities, have those handy from chapter 4 so that you don't have to work so hard to remember everything. I'm going to clear my screen and we'll move on. Okay, so you'll see that all of the remaining items on this page, this is going to be a review of techniques that you are going to use in simplifying your identities. So in this case, we see this word here that we learned in Algebra 2, and now it's going to become very important, is now in order to simplify some of these identities, you're going to have to be able to factor them. So I've written you some notes up here just as a few reminders. One of the things that you learned in Algebra 2 was how to factor something by pulling out a greatest common factor. So if you had something that looked like this, that you would say, well, A goes into both of those, and so then you would go and you would pull out the A from both, remembering to mark that space there. So in this case, when you go to look at A, then one of your techniques that you're going to be able to use next class is you're going to be able to know that you can pull out what is in common. So in this case, they both have a sign in them. So we have a sign, pull out a sign, and you get cosine squared x minus 1. Remember, you have to hold that slot. And so then as we're looking at this cosine squared x minus 1, we should know that it looks familiar to our Pythagorean identity. So here's my Pythagorean identity, which is sine squared plus cosine squared equals 1. So if I'm looking to get cosine squared minus 1, that means that I would have to be bringing the 1 over to the left side, which indirectly would mean that this sign would have to go over to the right side. So cosine squared minus 1 is going to be the same thing as negative sine squared x. So I'm going to have sine x times negative sine squared x. And so that's going to give me, if you think about it, you've got an a times an a squared, that's an a cubed. So this is going to be negative, sorry, I lost my negative. So this is going to be negative sine cubed x. And this will be my final answer. So I have factored it and I have simplified, if possible, using one of my identities. So the next thing I told you over here to remind you of, just some things to remember, is that in Algebra 2 you had the difference of two squares when you were factoring. That would be like a squared minus b squared, and you should recall that when that happens, that your middle terms cancel out, and so you end up having a plus b times a minus b. So when you look at this guy right here, I hope that's what you think, is you think, wow, I'm not trying to make this into an identity. They told me to factor it. You have to factor it. So this is going to be then the difference of two squares, which will be cosecant of theta minus 1, and then cosecant theta plus 1. You could do those in either order. I don't care. And when you're finished, you can clearly see that those middle terms cancel out and that you have factored it. And there's nothing that I can replace in here because that's not a cosecant squared. There is no identity there. If I change that to 1 over sine, I mean, you're just making your life miserable because then you got fractions. And so this is it. So when they say to you to factor and simplify, you can't simplify that any more than what that is. All right, let's move on. We'll try some more. Okay, so then we get to something like this. They're asking us here to factor that trigonometric function expression. So if you have to, then you go back to Algebra 2 and you remember how to factor something that looks like this. So if you're looking to factor something that looks like that, maybe you remember splitting the middle term. You do 3 times negative 2, which is negative 6. And so you're trying to find a way to make a negative 6 that also makes negative 1. So that would be a negative 3 and a positive 2. So I'm going to have 3x squared. I'm going to have minus 3x. I'm going to have plus 2x minus 2. So then remember, you pull out the common factor here. It's called factoring by grouping. So this is 3x, and this will be x minus 1, and this will be plus 2, and this will be x minus 1. And then you're going to have 3x plus 2, and you're going to factor by grouping times x minus 1. Now that's what it would look like if it was algebraic, but clearly it's not algebraic. It's trigonometric. So if you are going to use an algebraic method, then you must go back and replace the x with tan theta. So I'm going to have 3 times tan theta, which, by the way, I'm sure that there are people out there that didn't need the algebraic method that could have factored that without it. But I'm just trying to, from the beginning, show you an algebraic strategy in case you get stuck on something. I want you to go back to Algebra 2, and I want you to remember that this is no different than Algebra 2. So I've got 3 tan theta plus 2 times tan theta minus 1. And that is all I can do with that. I could change it to sine and cosine, but then I've got fractions, and it's a disaster. So here is my factored form and my most simplified form that I can have. All right, so unfortunately I've written over my other part here, but we'll go from there. So then you see something that looks like this in the next example. So we've got this, which again, if you think you can factor it without using the algebraic method, go right ahead. But I'm just going to go ahead and remind you of that. the very beginning of the year, I reminded you of the 4-2. And we said that when you see 4-2 constant, it is factorable. So in this case, I know that it's factorable by doing an x squared and an x squared. So then I'm trying to make a positive 1 that also makes a -2. So I should have a -1 and a -1. So that should get me, my middle terms will be -2x squared, and -1 times -1 is +1. So now that I've done that, I'm going to go back and I'm going to plug in my sign, which means this will be sine squared theta -1 factored sine squared theta -1. Now, it does say simplify if possible, and I should recognize, going back up to the top of the paper, that this can definitely be simplified using my Pythagorean identity. So if I knew that sine squared plus cosine squared equaled 1, then I know that sine squared -1 is going to equal, you can go back up to the top and you can play around with that, but sine squared -1 is going to equal a negative cosine squared theta. So go back up to the top of the paper, pause the video if you need to, play around with that Pythagorean identity until you get it. So this is going to be then a negative times a negative is a positive, and that's nothing more than a negative x squared times a negative x squared. So this is going to be cosine to the 4 theta. And this will be my final answer. Okay, all right. Also, at the beginning of the year, I showed you a pin that said, please don't kill kittens. Killing kittens is where you just bring this in like this, and you go like that, and then you've killed kittens. So if you're here at the beginning of the year, maybe you remember that, maybe you don't. So going back to Algebra 2 in my purple, I remember that when I have something that looks like this, I really want to see if I can factor this out first. And then maybe if I can factor that, then maybe one of these ones below will cancel. That entire factor will cancel. And then I won't have killed any kittens. So I should recognize this as the difference of two squares. That would be, in essence, if we were back in Algebra 1, Algebra 2, that'd be x squared minus 9. So I should be able to hopefully easily see that this is going to be sine x minus 3. And then sine x plus 3. And so now, you see, now I'm not killing anything. These will just, now those entire factors will cancel. So this entire answer here is going to really just equal sine x minus 3. So I'll put a box around that. But I would not have been allowed to just cancel those things in there. And if you're just looking at that thinking that that's just going to cancel up in there and that's how that happened, that's not how that happens. And so you may get to one where you actually have to factor it, so make sure that you remind yourself of the killing kittens. All right, last but not least, I'm going to try to do this without moving my screen. We get something that looks like this, which definitely we look at and we say, well, geez, you know, it looks like a quadratic. We really wish that we could be able to factor it, but we say, unfortunately, this, I have a red pen, this does not match this variable. Those two variables don't match. So oftentimes what you'll see them saying is they say, use your Pythagorean identity to rewrite in terms of one function. So is there a way that we can get all of those variables to look the same so we can factor them? And so hopefully, you know, you go back to your old Pythagorean identities and you remember what cosecant squared x equals. So let's think about this. We know it's going to be 1 plus something. So if you've forgotten, remember cosecant squared is 1 over sine squared. So you would need this guy on the right to be over sine squared. So cosine squared over sine squared is what is going to give that to you, which is cotangent squared theta. Remember, everything is going to get divided through by that. All right, so at one point you've already had this memorized, so you need to go back and you need to refresh your memory. So I'm going to then, you see what I'm going to do is I'm going to plug that in. I'm going to plug, let me get my purple and my brown. Okay, I'm going to plug this in into here. So I'm going to replace that by saying 1 plus cotangent squared x, okay, minus 3 cotangent x minus 11. So I'm going to clean that up by saying this is going to be cotangent squared x minus 3 cotangent x, and then a positive 1 and a negative 11 will give me a negative 10. Now that I have everything in the same variable, now I'm going to be able to factor it. So now I'm going to be able to factor it. And again, if you are struggling with this factoring and you can't do it in this way, then you want to come back over here and you want to write x squared minus 3x minus 10. And you want to go back to algebra 2 and you want to factor that. But I would think that this is going to get easier for you, that you should be able to do this without having to do that algebra step. So what makes cotangent squared? Well, that's cotangent x times cotangent x. What makes a negative 10? That also makes a negative 3. As or subtract multiplies to be negative 10. Well, you've got, 10 and 1. That doesn't make 3. You've got 5 and 2. Yes, that makes 3, and it's negative 5. So this is going to be cotangent of x minus 5, and then cotangent of x plus 2. And there is no additional simplification that we can do to that. This is going to be my final answer. So cotangent of x minus 5, and then cotangent of x plus 2. So we've done that. We've made it through our first thing where it says factor and simplify in order to sort of break down these identities. Okay, next up, we've done a few of these in the past. Now there's going to be more. So this says combine into one fraction and then simplify. Those are the directions. So in this case, when I see one fraction and I'm adding and I'm subtracting, I should remember very clearly that I cannot add or subtract fractions without a common denominator. If I don't have a common denominator, then I'm not going to have my algebra be correct. So if this has a denominator of sine, then you should recall slightly that I'm going to multiply this by sine over sine. Totally legal, because sine over sine is just 1. I haven't changed anything. So I'm going to end up with sine squared theta plus cosine squared theta, and that's going to be all on the top of my fraction, and the whole thing is going to be divided by sine theta. So I'm going to remember that I should always look out for my Pythagorean identities. So this right here is a Pythagorean identity, so I'm just going to kind of just say Pythagorean ID. Most of you are very good about listing that. And so you know that sine squared plus cosine squared is 1. So we're going to have 1 over sine theta, which in this case, the goal really is, when they say to you to simplify, you really want to try to avoid fractions as much as possible. So this real life answer here will be cosecant theta. That would be the most simplified form. You don't have any fractions in there. You got rid of everything that you needed to do. And so we ended up with cosecant theta. All right. So this one over here, we should see that this is a factor, right? And this is a factor. We need common denominators. So I'm going to multiply this one over here by secant theta minus 1. So this is going to be secant theta minus 1. And so secant theta minus 1. I probably should have written this on the next step down, but I got a little lazy here, and now I'm in big trouble because I don't think I can move this over. So Can't move this over, so we're just going to do the best that we can do here. So I'm going to multiply this guy by secant theta plus 1